All right, and we're back. Again, physical geography 1114. Um, Hopefully, all you students are starting to look at some of these tutorials so we can get you through the rest of the semester. Today, we're doing chapter 18, the topography of arid lands. Again, I think I can get all of this on one tutorial. Might be a little long. You might have to look at it in two pieces. But hey, that's the great thing about YouTube and tutorials. You can always rewind, pause, stop, come back, look at it again. It's great. You get to see it over and over and over again. And if you want, you can put a little piece of paper down in that bottom square where you see it in my happy face and cover that up and turn the volume off and just look at the tutorial. That's up to you. All right. Again, we are using the Pearson book, McKnight's Physical Geography, A Landscape Appreciation, 12th edition. All right. So I know I say that a little bit different every time. I'm just trying to keep myself from getting in trouble for plagiarism, right? Because you know people get picky. All right. Here we go. All right. The topography of arid lands. It's a specialized environment because there ain't a whole lot of water, so the wind's got to do the work. Again, running water in waterless regions, the work of the wind, characteristics, and two representative desert landforms. We're going to fly through this. All right, desert terrain, stark and abrupt. So what happens? You got grass, 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 and then you got sand. Okay, that's all there is to it. You go from some grass to desert. There's special conditions. Weathering is mechanical. Weathering is dominant, slower weathering, and angular particle formation. And that is because, as I explained, with a river or a stream, the rocks and stuff are being rolled around. They're grinding against each other, and so they get smooth and pretty, just like your rock grinder you had when you kid. Your rock shiner when you were a kid. Okay. However, here in the desert formation, the only thing that's really doing a lot of work is the wind. And so the wind's just banging those rocks together, breaking them off in chunks. And that's why you get that angular formation to them, okay? Soil and rig list. Soil is absent or thin. A lot of times you don't find any soil at all. In fact, I can tell you right now, some places, don't get me wrong now, there may be sediment. Remember, sediment's different than soil. Soil, you got to have that biological factor. Sediment, you have sand everywhere. And a lot of places, I want to explain this right now, most deserts don't have a lot of sand. They're a rock. They're a hard base rock, okay? Because the sand all piles up in one thing called sand dune. That's where all the sand is, right? The rest of it, flat rock, okay? So soil is thin or absent, exposing the bedrock. So we got that bedrock. Soil creep, minor due to the lack of soil and lubricating effects of water. So you don't have a lot of movement because one, you ain't got no soil and you ain't got no water to keep it lubricated so it can move. Okay? Some more special conditions. Impermeable surfaces. Impermeable means you can't get water down to it. Why? Because it's bedrock. Okay? Cap rocks and hard pans. We've already talked about cap rocks and hard pans. That's that more resistant strata that's on top. Softer stuff underneath, more resistant stuff on top. Okay? High water runoff because it's dry and hard. Let me explain something, especially out in western Oklahoma. You got the sun beating on that ground over again every single day, and the wind just sucking all the moisture out of everything, and that dirt gets hard. It gets hard as a rock. You don't dig it with a little trowel, you get out there with a pick, okay? And even then, sometimes a pick is going to make you do some serious work. But it's cap rocks and these hard pans, okay, are more resistant. But they're due to high water runoff because there's no water that can saturate into the ground, okay? They don't, usually out in the desert, you get a thunder boomer, right? So you get a lot of water all at once. The ground is so hard it can't penetrate, so it just runs off, right? Whereas you get out like eastern Oklahoma, what have you, out in the eastern United States, you get those nice spring and fall rains, and the ground has time to absorb some of that. Yeah, you get thunder boomers, but the ground's a lot softer, so it absorbs more of the water. Sand. Some deserts have sand abundance, allows for the water input into the ground, and easily moved by rain or wind. So again, we do have the Mojave Desert. There's the Sahara. But most deserts, again, they don't have a lot of sand. It just depends on where you're at. It depends on those coastal winds. Are they blowing the sand in, or is it just hard rock because the wind's going the wrong direction, okay? Rainfall. Most streams are ephemeral. Part-time stream only happens if there's a thunder boomer, right? Thunder boomers, lots of rain all at once, water run off into the stream. As soon as that water runs away, flash flood, it's done, okay? Effective agents of erosion, though. And I'm going to say more, not so much erosion. I mean, yeah, it's going to do some erosion. The wind, though, has been working on, nonstop, especially western Oklahoma. We've seen that slide. Windiest place, western Oklahoma, right? Hottest, driest place, western Oklahoma. Okay. So anyway, we have these streams that come down, but what the streams really do is they transport. They pick up all that dust and sediment that's been banging around, beating, breaking down. They pick it up and they transport it, okay? And you end up with these huge, like, mudslides and what have you, okay? Alluvium, unusually common in deserts, okay? Unusually common. Again, alluvium is toted by streams, okay? But it's common because it's sediment, okay? The wind action shifts particles. The wind is constantly blowing things around. Like I said, beating and banging, breaking things off. Again, it's not rolling it and smoothing it and shining it. It's just smashing it together, okay? All right, basins of interior drainage. Most watersheds do not drain into any ocean. They don't, okay? There's no major streams running through these. The water transfers to the base of the valley with no external outlet. No external outlet. What do we got now? A saline lake until it dries out. So you get salt sediments, okay? Vegetation, there's a lack of continuous vegetative cover. Why? Because there's no soil. You got to have soil for something to get roots and nutrients. If you got no soil and all you got's rock and a little bit of sand, it takes a long time to get vegetation growing, right? And then what little vegetation there is, it's grabbing all the water and moisture first, right? It's not going to let anything else grow. It's like, hey, it's raining today. I need a drink, okay? So running water, the most important external landform agent, external, okay, coming from outside. So again, we got all the dust, debris, sediments floating around, flying around, right? And then you get the thunder boomer, it knocks everything to the ground and flows it out, okay? The erosion, tremendously effective with little plant cover. Again, if there's no plants holding anything in place, it depends on the grade or gradient, which is based on slope. So how steep is this area? Okay, and how much water you have, okay, your discharge, gradient and discharge. If you just got a little bit of rain, you're not moving a lot of stuff, right? If you don't have a lot of slope, you're not moving a lot of stuff. But if you got a steep grade and a lot of discharge, you can get a whole lot of mud flowing and debris flowing and everything else, okay? The intensity of the rain combined with impermeable land surfaces create this intense runoff. Flash flood, okay? That's simple. Intense runoff, flash flood. There's an unpredictable imbalance between erosion and deposition, all right? And that's because, again, it's a dry environment and you have ephemeral streams. You only get thunder boomers every once in a while. One of my dig sites we'll talk about later out in Buffalo, Oklahoma. This guy lives literally like in a void. The storms either go north of him or south of him. He lives in a void until I went out there to do my dig, and then he got rain every day, and he wanted me to stay forever because he was getting rain. But he lives in a void, and there's places like that. The storms just go with the jet streams and stuff. They just tend to go around things. All right, so surface water in the desert. First of all, exotic streams, and I've already talked about this before. Here we go with the Nile River. Permanent streams that originate outside of arid lands. Okay, originate outside because there ain't no water. There's no spring or something like that that is actually fueling these things. And again, no tributaries. Okay, they really don't have any tributaries. All right, ephemeral streams periodically flow, result in intense erosion, transportation, and deposition. Again, thunder boomers. You turn around with a flash flood, it carries all that sediment, which turns into mud, so you get a nice mud flow. Desert lakes, playas. Okay, now playa is a temporary, it's a lake, but it's a pond, okay? So you got a low area, no external outlet. The water goes into this area, and it sets there. And the thing is, it's not really I don't want to call it a saline lake. Lakes are more permanent. A playa usually just lasts for a couple months. Animals will come in, they'll drink as what they can when they can, but it's going to dry out by midsummer, okay? That's a playa, okay? It's a low area in the basin that accumulates the water runoff when it does rain, but it's by no means permanent, okay? Salinas, dry salt lake beds, all right? That's when the lake is completely dried out, okay? You go up to the salt plains up here in northern Oklahoma, northwestern Oklahoma, okay? That's a salina. We got salt out there because it's literally evaporated, right? Salts and evaporate, okay? And saline lakes. If there is no external outlet, it becomes a saline lake, right? Okay, you got to have an external outlet for it to be fresh water. All right, fluvial erosion in arid lands occurs during a small portion of the year, flash floods, okay? So again, ephemeral, Part-time, you get thunder boomers. Whenever you get a thunder boomer, boom, it's done, and then you're dry for the rest of the period, or for a long time anyway. Differential erosion, variations in slope and shape of landform from rock type variation. Okay, we've talked about this a little bit, and I know that's a lot of words there. I probably should have cut that down. Differential erosion. Rocks weather differently. It depends on how hard they are or how soft they are. Okay, it's like a stream. It takes the path of least resistance. The softer, easier, more erodible rocks are going to erode away faster than the hard, more resistant rocks. You usually have a hard pan or a capstone on top, softer stuff underneath. The softer stuff gets eroded when it rains, it gets eroded away. And then the big stuff, mass wasting, remember that word, mass wasting, the heavy stuff, the more resistant stuff is heavier usually. It'll break off, okay, and slide down the slope, all right? That's the erosion, okay? Residual erosion, surfaces, Inselberg, Bonharts, and pediments. We're going to see that on the next slide, so it's easier to talk about on the next slide. Desert stream channels are ephemeral stream beds, part-time, okay? And again, this goes back to our intermittent and what have you when we did streams. Ephemeral, intermittent, seasonal, part-time, then you're arguing semantics here. All right, so here's our characteristics of a desert pediment. All right, first of all, the pediment itself is this sloped alluvium here, okay? Sloped alluvium, right? That's what gets washed out, okay? They're called alluvial fans. So all that dust and stuff is sitting up in the canyons. You get a thunder boomer, and it washes all that mud and all that sediment down, okay? It's the angle. The pediment's the actual angle from where you come off the mountain into the flat plain, okay? Alluvial basin fill. That's where everything will finally go as the thunder boomers. It keeps rolling out, rolling out. Here's your Inselberg, right? It's a residual mountain peak or a residual mountain. So it's been weathered down. Remember, as the landscape goes down, as far as mountains, your basins and stuff are filling up, okay? Mountains are going down, basins are filling up because the sediment's coming down. It's got to go somewhere. It goes into the basin, and the basin fills up, okay? So there's your pediment, and there's your alluvial basin fill and your residual Inselberg, okay? All right, talus accumulations at the foot of the steep slopes. Okay, so we get talus. That's the big rocks. Okay, so if it's steep enough, the big rocks, as they break off, are just going to go downhill. That's your talus, okay? Piedmont zone at the foot of the mountain range. Okay, so here's my Piedmont, right? That's where it starts to flatten out, right? And the Piedmont angle is the angle at which it flattens out, right? Is it steep? Is it not so steep? It all depends. What's your slope? The basins of interior drainage covered with fine particles as flow, volume, and speed are low. So again, we come off, we got a lot of gradient here. We discharge, here we go, boom, we're losing some of this stuff as it starts to flatten out, and then it gets flat, and the flatter it gets, the slower the water is going to go, and all those sediments start falling out by size and by weight, right? Wind as a sculptor is a relatively limited effect. The wind's blowing, but it can only do so much. It's got to be a heavy wind. It's got to be able to pick that sediment up and really get it blowing around banging. Wind just blowing is just blowing, okay? Air right near surface has zero wind. Otherwise, right next to the ground. And that comes back to one of the chapters we had way back at the beginning of the semester. It's called friction, right? The higher you go, the faster the wind's going because you don't have any friction. You have nothing blocking the jet stream, right? The lower to the ground you get in the weeds, so to speak, got friction. It slows that wind down. But then as that wind gets up above that, the wind gets higher above that, faster it goes, okay? Effects of wind shear. Wind shear is just sharp winds that are usually sometimes, like, I want to call them eddies. But it comes off an object and it picks up speed. So you got that friction, then all of a sudden you don't have the friction. Now, aeolian processes, wind-blown processes, okay? That's what aeolian means, wind-blown, okay? So we had alluvium with fluvial. Now we have aeolian, which is wind-blown, okay? Wind-blown. Now, one of the things I want you to know is aeolian can be spelled two different ways, okay? It can be spelled with the big A or without the A. Either one is legit. So here's some aeolian erosion. Two effects, deflation and abrasion. What's deflation? Deflation is a blowout. Okay, deflation, lowering the ground. Here we go right here. See how this area is lower? It's deflated. That material has been broken down and blown out of there, okay? Shifting of loose particles via the wind, blowouts. Abrasion, that's where something keeps grinding and grinding and grinding against that rock, right? You got enough sand and dirt going around. So abrasion requires tools such as airborne sand and dust, sculpts the landforms already in existence. And here is our beautiful rock. It's been sitting there for who knows how many thousands of years, right? But you can see how scored it is. And these are known as ventifacts, okay? Ventifacts. Now, if something, and we'll get into this a little more, but if something has been sitting there, it actually builds up a glaze on it, okay? And they can use that glaze to try and date rocks. But, as I've said before, what do we know about dating? Let's say that rock has a glaze on it. Great. And then somebody kicks the rock and flips it over. And then the glaze starts to build up on the other side of the rock. And then somebody comes along, kicks it over again. Well, how many times has it been rolled around, kicked around? Did all the glaze, become apparent on the rock at the same time? Or did it, manifest over long periods of time depending on how it was exposed to the atmosphere? Got to ask those questions. That's why I say always ask questions, right? All right, aeolian transport. How do we transport this stuff? Well, if you remember, I told you, if you could get the alluvial one down with the bed load and stuff, you could get this one down too, because there's only one difference. There's no water, which means there's no dissolved load, no clay, okay? So, no dissolved load. All the clay is still attached to the sand and the silt, or the big rocks and boulders, whatever. There's no dissolved load. That's the only difference, okay? So, your bed load, guess what? We still have traction. We still have salutation, and just like water, we still have suspension. Now, depends on how strong your wind is, right? Not saying it's going to pick up big rocks. Tornado will, maybe. But your suspension is, for water, your suspension is more of the silt, and the dissolved is the clay. Here, suspension can be sand, it can be dust. It's different particle sizes. It just depends on how strong that wind is. If that wind's strong enough, yeah, you've seen the movies and what have you. They can come up with some big sandstorms, right? All right, dust storms. Again, most of them ain't necessarily sandstorms. They're mostly dust, right? They pick up all that loose stuff and just blow it around, make it hard to breathe. Larger particles move by saltation, curved trajectory, and traction, rolled or pushed, just like the alluvial, okay? And then you have creep by saltation, right? It just kind of creeps along. But you can also have, if you got a little bit of rain, you might have a little bit of creep if you've got the soil and what. That, again, there's not a lot of creep. There's usually not water. There's usually not soil. Okay. All right. So aeolian deposition: fine sand laid as thin coating, no landform significance. It's sediment. Don't forget, it's not soil. It's sediment. The coarser sand is deposited locally, so we have sand plains or sand dunes. Remember this. Okay, it's just like anything else. The wind is just like the water. The bigger, heavier stuff is going to fall out first as the wind slows down. So the bigger, heavier stuff falls out, the lighter stuff stays up, okay? Desert sand dunes. Some dune fields are composed of unanchored sand moved by local winds. And then there's that slip face, okay? So, real quick, what's slip face? The slip face, remember, and I said this was sand. What is the angle of repose? And I can't really write here, but it is 33 degrees, okay? 33 degrees, don't forget that. 32 to 34, but the average is 33. And there's that slip face. So what's it mean? It means once this gets to 33 degrees, right, the pebbles start falling down the other side. And they start filling up, right, until we're not at 33 degrees. And then it's got to build up some more. Angle of repose, okay? So there's your slip face, and there's your angle of repose. All right, desert sand dunes, the three most common dunes, and I always mispronounce these. The Barcan, individual dunes migrating across the landscape, crescent shape. Remember now, and I said this when we talked about aeolian and some other stuff. Sand dunes, right, they migrate and they're active, but they can become dormant. If they can find something to anchor against long enough for there to be some moisture and some vegetation growing, they can become dormant. However, if it gets so dry that the vegetation dies, or there's a big, fire or something like that, and the vegetation dies, then what happens? that dune can become active again because it's so dry as the wind picks and breaks apart them little pebbles that are making that dune, holding it together, right? It's going to do that. So, Barchan, individual dunes migrating across the landscape. And then we have transverse, supply of sand greater than, for Barchan's crescent shape, the entire landscape is made of these dunes. So we got transverse. And then seeps, long narrow dunes that are parallel in orientation, seem to represent an intermediate direction between two dominant wind directions. Two dominant, doesn't say which way, okay? Now, here's some Barchans, all right? They usually got these here. So what happens is this literally is migrating this way. It's going to blow this sand up. It's going to come down on this slip face here, boom, 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 and it's going to migrate. And along with it, these legs or anchors, whatever you want to call them, they're going to migrate too. Now, I want you to look at all this here. It looks like this sand is laid on a tabletop, right? Look at that. That's all flat. This is the desert in Namibia. Okay, that's hard bedrock, folks. That's what I'm talking about. There's sand there, but there's not a whole lot. And what sand is gets put up into 1 or 2 or 3 dunes. The rest of it's hard rock. It's bedrock. Okay. All right. So common types of dunes here. Here's our Barchans, right? The wind direction. So it's blowing this way. Again, transverse, similar to Barchans, but much longer. All right. And here's my seep. 2 different wind directions, all right? 2 different. Now, Oklahoma has 2 main wind directions. Okay, so we're talking like Little Sahara or someplace like that. Guess what? North in the wintertime, south in the summer, 2 main wind directions, okay? And then we have these stars. Stars are like blowouts. The dune itself, this is the dune. So this is the star dune, but this is a blowout, okay? So you got these wind directions coming from different ways, so you got it blowing it out and putting it up in piles, and so you get a star along with a blowout, okay? All right, alien processes in non-desert locations. So again, wind blown. Well, guess what comes off the Antarctic ice sheet, the Greenland ice sheet, and at one time the Laurentide ice sheet, which was over North America, extended all the way from the Colorado Rockies to Greenland. It was the Laurentide, biggest ice sheet ever. All right, and extended all the way down to Nebraska. Well, if you got that cold, what do we say? Polar deserts, right? It doesn't mean, desert doesn't mean necessarily dry. It is dry, don't get me wrong, it's dry. But it doesn't, there's no differentiation between cold and hot. That's where people like to say it has to do with moisture. It's dry. It can be either hot or it can be cold. You got polar deserts, Arctic deserts, whatever you want to call them, and then you got hot deserts like the Sahara, okay? Desert simply means dry. Remember that, okay? So some coastal dunes, ocean waves deposit sand on beaches. Depends again on the wind direction and tides, all right? We typically see more sand on the west coast than we do the east coast. Now, I'm not saying all the time. There are of course, regional differences. But usually on the east coast, you get up towards Maine and places like that, you're going to find some sand, but not nearly as much as like you're going to find on the west coast, okay? It's not nearly as much. And then the prominent onshore winds move the sands inland. If there's nothing anchoring them, it keeps on blowing it. All right, loess. What is loess? Loess is wind-deposited silt. Silt, not sand. So, glacier, Laurentide ice sheet, we got the glacier, all right, and it's pulverizing that rock. The sand and gravel and all the big boulders stuff, they get washed out of the bottom, okay? And we'll get more to this in chapter 20, but or 19. But they get washed out the bottom, right? It's the stuff that's the being blown around, the dust and stuff that's being blown around by the wind coming off that cold ice, right? Again, it's a desert, and that's the silt, okay? Again, Oklahoma, we got a lot of clay because our stuff comes from like Colorado. By the time it gets here, all we get is clay. We don't have basements on our houses, but you get up into Kansas, Nebraska, Iowa, on further north, they've got basements. Why? Because they've got silt and they've got lots of loess. Oklahoma does have some loess deposits. Don't get me wrong. Okay, they do have a few that's either been blown down or transported via streams. Okay, outwash streams. But for the most part, we don't have a lot. Okay. It lacks horizontal stratification, and that's because it's all basically one size, one color. So again, here is my loess. This is a loess deposit. Look at that. You can't see the individual strata layers, okay? Great vertical durability. Again, it'll stack up and get anchored. It'll stay that way. But you burn all that vegetation off and let the wind pick up, it'll break down just like sand dune. Okay. Again, formed during periods of glaciation, just like the majority of our natural lakes. Most of our natural lakes are here because of glaciation. And again, we're going to get into that in chapter 19, glaciation. All right, so here's some of the major lust locations of the world. Again, here, look at this. See, it's all up in the northern and southern latitudes. All right, that's where all the lust is, up where the ice sheets were. Look at this. That, we got just a little bit here, but this here is the Kansas, or not Kansas, but Oklahoma, Texas, right? Somewhere in here. Yeah, there we go. Okay? We didn't get a bunch of lust. Okay? We didn't get a bunch. All right, some characteristics of desert landscape surfaces. Ergs, seas of sand. These are places that do have a lot of sand. Okay, Sahara, large areas covered with sand and dune formation from the wind. Hypothesized to have originated in more humid climates, more moisture climates. So again, we talked about the petrified forest, right? The big red sequoias that are petrified like rock, in Arizona, okay? So at one time, Arizona had to have a whole lot more moisture. Goes back to plate tectonics. Things are always changing and moving, all right? Here we go, seas of sand. So at one time there was grass and stuff, and then the climate changed, right? And it died, and it allowed for all this sediment stuff. Drying climate combined with wind created the formations see today. Again, the Saharan and Arabian deserts, lots of sand, okay? I want to be careful when we say that about Saudi Arabia. It all depends on where you're at. If you're over on the west side of Saudi Arabia, I've been there, okay? Been there. Saudi Arabia near Riyadh, lots of sand. If you're out where I was, Dhahran, rock. There's some sand, don't get me wrong, but more rock than anything, okay? And yeah, it's a pain, okay? Let's put it this way. Whenever we had a storm, we had to tie our tents off to our trucks, okay? Because there's no way you're driving spikes into the ground. All right, Rig, stony desert, tight covering of coarse gravel, pebbles, and or boulders, also known as desert pavement or desert armor, okay? This is more like what I had, okay? I had the Rigs, the stony desert. All right, desert varnish. Okay, so I was talking about my Vinifac a while ago. This is where that desert varnish comes in, and they say they can use it for dating. Again, always question dating methods, okay? Was the entire rock covered, one side of it covered? All those things play a factor, okay? Dark, shiny coating consisting of iron and manganese. Now, manganese is in water tables, okay? We've talked about that in class. I'm not going to go back into it. I hate it because I have to deal with it with my mammoth sites. Manganese oxides, right? So anyway, it's a shiny coating, and they can try and date that based on the shiny coating. Desert varnish, a useful dating tool. Always question dating, always. I've had some issues. Hamada, barren bedrock, barren surface of consolidated material. Consolidated. So what's the difference between unconsolidated and consolidated? Unconsolidated gravel, what have you, it breaks apart, okay? It's not consolidated is when it's rock, okay? It's cemented or melted or whatever, it's rock, okay? It's consolidated. You just can't break it apart, okay? Sandstone is consolidated. River sand is unconsolidated, okay? There you go. Exposed bedrock or cemented sedimentary minerals. So you have either one. So regs and armadas are extremely flat. Okay, extremely. All right, here's my basin and range. I've already talked a little bit about this, so we're going to go ahead and talk about it a little more here. Largely without external drainage, saline, no external outlet. Okay, usually it's just a low area, and it's a temporary low area, right? It's just going to take the water for that one rain and be a low area, something for the animals to come drink out of for a couple of days, and then it dries up. Numerous in fault block mountains. So remember, we got our Horst and Graben, right? Fault block mountains, okay? And we have three principal features. So first of all, here we have, I want you to remember this, okay? If you have just one, it is an alluvial fan. Excuse me, okay? There's an alluvial fan right there, okay? Here's my range, here's my basin, and my basin, the lowest point in the basin can become a playa. And a playa is a temporary pond or lake. Okay, very temporary. Now, if I have more than one alluvial fan and they begin to coalesce, they become a bahada. Okay, that's a B-A-J-A-D-A, Bajada. Okay, so how do we, these alluvial fans of Bajadas, some of them are huge. Okay, so all that dust, all this erosion has been going on up here in these range areas, up in the hills. Okay, beating and baking, breaking all these little particles of sediment loose, and they've all been laying there on the ground. And then along comes your thunder boomer, and that's when you get this huge mud flow. Okay, you get a huge mud flow, and some of these are huge. Okay, so anyway, range, alluvial fan, playa. Make sure you remember these. You're going to see them again. Surface features shaped by weathering and mass wasting and fluvial processes. So shaped by the weathering, aeolian, mass wasting, softer stuff gets eroded, bigger stuff breaks down, okay, and fluvial process, a thunder boomer comes along and then moves it all into an alluvial fan, and if it gets big enough, it becomes a Bajada, okay. Long, narrow ranges of different elevations, and it goes back to the differential weathering, okay. All the ranges, it depends on, you know, what their makeup is and what have you, their geologic makeup. All right, so the Piedmont zone, pediment zone, sharp break in the slope. So that sharp break, when everything starts to flatten out and the materials start to flow out of the flow of water, okay, that's that Piedmont zone, or pediment, okay? A sharp break in the sharp slope that marks change from range to Piedmont, okay? Underlain by erosional and the pediment, okay? Alluvial fan, channels of Piedmont break into distributaries, just like deltas, okay? Because again, you can see all these small rills in here. Okay, look at all these. Okay, and the next time that there's a thunder boomer, flash flood, mud flow, it's going to pull a lot more of this stuff out, and it's going to fill these up because that's where they're going. It's going to fill them up with sediment, and so the water will have to find another path. Okay. Deposit new material on old material. Again, coalescing alluvial fans are Bajadas. Okay, B-A-G-A-D-A, right there. Okay. There we go. Now, I want you to take a look at this. This is an alluvial fan. Folks, this is a road. More than likely, I'm going to say it's a two-lane road. That is a two-lane road. Just goes to show you. Now, most of these, if you get some plants in there, you can anchor them down, and supposedly they're pretty good for crops, right? Pretty fertile. Lots of people do. However, do you really want to be somewhere where you find an alluvial fan? Do you want to build a house or something there? No, because if it's been flash flooded and it had a mud flow once, it's going to happen again. So don't ever sit there and be like, oh, this is so pretty, I want to buy a house here. Just think, how was it made? How was it created? Why is it there? And if you go, oh, it's an alluvial fan, Mr. Cox told us about this, yeah, don't build a house there. All right, the basin, the flattish floor, very gentle slope on all sides towards a low point, which is where the playa is. Again, shallow, ill-defined drainage channels. They're not permanent. They're distributaries. Salt accumulations, commonplace on playa due to evaporation of the water. No external outlet, therefore it is saline. And these are known as playa lakes or ponds, but they go by playa lakes, but they're not very big. They're really actually quite small for the most part. There are some big ones, but most of them are pretty small. We've got a few of them here in western Oklahoma that you'll run across. I've been on a dig on one, and it was a playa, and it was not very big at all, you know. So, basin floors covered with fine grain material. Again, as that flow slows down, the bigger stuff fell out on the slope as it was coming down. As it flattens out and that water flow slows down, then the finer stuff comes out. Death Valley, a prime example of a basin or range, because we talked about this before. You got the Horseshoe Graben, you got the ranges all the way around. Remember, Death Valley is below sea level, which means if there was an external outlet, the ocean would flow in. But it's dry like a desert, okay, which means there's no external outlet. So it, again, is more like a playa or a saline lake, a salina. So here we go. Here's Death Valley. Excellent example of basin and range to range. Again, Graben, large portions of valley below sea level. Remember, the horse is up, the Graben's down, okay? And it has surrounding ranges. It also has these coalescing Bajadas. As this is weathered down, it has started to move out, so it's starting to flatten out more. The Piedmont at foot of the mountains is alluviated into a complex fan structure, that Bajada. Basin filled with alluvium, okay? Alluvial, okay? Salt pans and mobile dunes in the basin. So, all right, It's got salt there. Now, it does get cold enough. When I've talked about this in class, if you want to look it up, it's pretty cold. It's called the Rock Raceway. You're not supposed to move rocks and take things from any of these places. Anything that's a national park, you're supposed to leave it alone, right? Leave it there. But there are people who are out there, they're running around. And their scientists are like, wait a minute, these rocks have been moved. And they can see like it's got a crack, like something's been pushing along. It's like somebody pushing and kicking the rock. What's going on? So they set up cameras, and it gets so cold there at night that a little bit of frost builds up on the rock, just enough to lift it just barely above the sediment. And then as the sun comes out, it melts, and so it slides along, right? It just slides along just a little bit. So they set it up there, and sure enough, this rock moved like a foot over like a 6-month period, and it was leaving a trail behind it. And they call it the Rock Raceway. Okay, it's pretty cool. Oh, an in-class prompt. What? All right. So over on the left is me with the Granfield Mammoth Tusk. Again, southern Oklahoma, southwest Oklahoma, dry, hot cotton country. Me over on the right, upper right is Buffalo Mammoth, and again, that is a hot, dry. Like I said, he had more rain when I was there, but as you can see, I'm having a good time. I was a whole lot thinner. I'm telling you, when I'm out on my digs, I lose some weight. And then there in the middle of that is a Helena Mammoth. Again, a hot, dry area. Ask anybody that's ever worked with me, been out in the field with me. You probably don't want to go with me. I don't get a whole lot of volunteers because you're so exhausted after about 2 hours. You're like, there's got to be a better life than this. But hey, I love what I do. Okay. So anyway, there's a couple of things going on here. So again, pay attention to the detail. The detail is everything. All right, another representative desert landform assemblies, the mesa and scarp. So this has to do with our differential weathering. So first of all, mesa, Spanish for a table, flat top. Now, there's a difference. There's mesas, then there's buttes, and then there's pinnacles, okay? And we have this mesa. So this is that more resistant cap rock right there, okay? This underlying stuff, some of it's more erodible, some of it's not. And so the scarp face is that face, cliff, whatever you want it, it's a scarp face, okay? It's the break off. So we got our incline slope. So this erodes away, right here, erodes away, until this becomes too heavy, and then once this is too heavy, boom, it breaks off, mass wasting, slides down the hill. Okay, now, what's the difference between a mesa, a butte, and a pinnacle? Well, first of all, we've got our plateau. This is my plateau out here. Plateau's big flat area. Now, I can't write what we got on here, but then you get the mesa. The mesa is closest to the plateau and large. I've looked for it, and I can't find it, but I found or heard sometime there's actually dimensions. It's kind of like an air mass. It has to be so big to actually be considered a mesa. Okay, but here is my mesa. Okay, boom, right there. If I can, there's my mesa. The next furthest one out is the butte. The butte's smaller than a mesa. Okay, and then a pinnacle. Pinnacle's a little bitty thing, usually out even further away from the plateau. And a pinnacle literally is like a small point that comes up, and it's just got a little bit of cap rock, right? Maybe big enough for 1 or 2 people, maybe 4 people to stand on it. That's a pinnacle, okay? It's small. Buttes, a little bit bigger, and then you get mesas, which are even larger, and then you get around to the plateau, okay? Again, associated with horizontal stratification, you got to remember, usually when you find these places, these are associated for the most part, not always, but with inland seas, which means sediment stuff that washed in, and has that horizontal stratification that's built up, okay? And then the sea went and evaporated, which is where you get your more resistant rock here, okay? Usually your more resistant is an evaporite of some type, and then maybe there's a lot more water that comes in, so you get more layering on top of that, and then evaporite, and then more layering and evaporite, okay? Variable resistance to erosion in the strata. Again, differential weathering. And then again, we have plateaus, dirt plains, same thing, okay? That's what we're talking about with the butte and pinnacles, okay? Sapping, groundwater seeps out of the scarp face, okay, and erodes soluble material. So ground sapping, okay? And that's just because usually on the top of these you do have plants and stuff, and those plants will hold moisture, okay? Buttes, small surface areas and cliffs that rise around the surroundings. And then we have pinnacles. So buttes, mesas, and pinnacles typically found near a retreating escarpment face, most likely, not always, but most likely associated with a plateau. Okay, this here is a typical butte. Okay, that's butte. This here, that little point right there, that's what I'm talking about, a pinnacle. This is a butte. This is more like a pinnacle. Okay. All right, the Badlands. Overland flows from occasional rain develops tiny rills expand into ravines and gullies. Again, gullies and stuff, ephemeral, part-time. So these rills, because of the rain, it just got bigger and bigger and became gullies and stuff. Could you imagine getting lost in that maze? You would wander around for days. So again, characterized by a maze of ravines and gullies, lifeless and nearly impassable. Look at that. There is no vegetation. Make sure you take your water with you and a food source. All right. Arches, natural bridges, arch formation, natural bridge formation, and pillar formation. Folks, I know my face is covering this up, but this is what I'm talking about, your inland seas and what have you. Folks, this is due to water. Okay, the water etched that out. So the water level at one time was way, way up. Okay, and it caused all that erosion. So water up will flow back and forth. It sculpts certain things because it washes around. You got eddies and rapids and nick points and everything, and it's doing its own erosion thing. And then the water level goes down. And once it goes down, instead of sculpting big on the big surfaces up here, it incisors and deepens. Okay. All right, look at that. We got through another chapter. So I'll get this saved up. I'll get it posted and let you know about it. I was glad to talk to my students today. Had a great time. Hopefully you guys are getting the valuable information you need off these tutorials. And it's going to help you out because we're all going to get through this coronavirus thing together, right? So peace and talk to you later.